Welcome back, my 8th grade YouTubers. So, obviously this is our new YouTube video for this week, and we've been studying something called a system of equations. Systems are anything more than one equation. So we can have 2, 3, 4, 5, as many equations as we want. But we're going to start with just two different equations. And what we're always looking for is when we have more than one equation, we need to find a solution. And when we're finding this solution, you're probably thinking, okay, well, what does the answer look like when there's two equations? What we're trying to do is we're trying to find where these two lines intersect, where the two lines are going to cross each other. Now you can see one of these equations says y equals negative 2x minus 7, and the other one says y equals 4x plus 5. So if we graph these, this could take a really long time. We could probably go ahead and say, okay, let me do it the quick way, Mr. Gonzalez, the way that you kind of taught me in class. You taught me to look at the y-intercept number, and I'm going to graph this one right here in green. I look at the y-intercept, which is negative 7, so I'll put a dot right here on top of negative 7. And then I'll go ahead and notice that this line has a negative slope of 2. So I'm looking at this slope number here, and I'm looking at this y-intercept number here. Well, I'm going to do the same thing for the other graph, but I'm going to graph this one in a darker shade just so it doesn't look like the other one that I'm going to graph on this x and y axis. So I'm going to look again at my y-intercept number, which is 5. This is where it's going to cross the y-axis. The y-axis is the vertical line going up and down. So I know this line, when I graph it, it's going to pass through the number 5 on the y-axis. That's why these numbers here are called the y-intercept. These y-intercept numbers are always the numbers that are not multiplied by the variable x. So I noticed that it has a positive slope. So now what I'm going to start to do is I'm going to use these slopes that I went ahead and wrote slope negative 2 and slope positive 4. I'm going to go to my green dot, and I know that this line must be going down from the left to the right. So from the left side to the right side, because this equation has a negative slope, I know that the line is going downward, and it must be going downward, and it's not only going downward, but it actually has to cross through this point where y is equal to negative 7. So I know that it's from the left to the right going down. And I know that it must pass through negative 7. The other line that I'm going to graph, this line is going to pass through y is equal to positive 5. But this line from the left side to the right side, this line actually must be going up. This is going to take a while if you're using the graphing method to figure out where the two lines cross each other. After we're done with this, I want to show you a really quick way that we've actually gone over in class. And I want you to stick with that other method, because this graphing method, as much as a lot of us like to see what the answer looks like, where the two lines cross each other, it takes a long time to do it this way when you're using this method. This method actually has a name. It's called the graphical method. And the reason why it's called the graphical method, well, you guessed it, is because you're going to graph it on the x and the y coordinate system. This is your x-axis, and this is your y-axis, and you're going to graph it on the coordinate system. So let's go ahead and draw what our graphs are going to look like for our two different lines. We have our first one right here, and so we're going to go ahead and say, okay, this line, and of course I want to use the correct one, so I'm going to use this green marker so it sticks out. I'm going to go ahead and say, okay, the line needs to be going through negative 7, and so I'll go ahead and I'll say, okay, the line's going down, and so I'll make the line going down, and it has to pass through negative 7, and this is going to be y is equal to negative 2x minus 7, okay? So my slope said negative 2, so I made the line go down. This is a quick sketch of doing it. Usually it takes even longer to do this because you have to pick x values and then you have to find out what the y values are, and then you have to graph them, and of course, that could take a long time. I'm just using a quick way of saying, okay, my y-intercept is -7. I put my dot right there on top of the y-axis where it's -7. My slope is -2. The line should be going downward from left to right. Usually it takes a longer time if I'm not using this quick sketch method. This is a quick way of drawing the graph, just a nice sketch of it. Let's use my other graph of this line for this equation, and I'm going to graph this one for this function. We've used that word before and we know this word. These equations are linear functions. So I know this one right here should go through y = 5 on the y-axis, and I'm going to go ahead and know that this line is going upward. So what I want to go ahead and do is I want to make my line go upward, and I want to make it go through where y = 5 here. Now, if I go ahead and I look at my graph, I can see these two lines are going to cross each other, and of course I do want to write this one, y = 4x + 5. And I want to go ahead and show you that these two lines do intersect right about there. So let's see what our x value is. Our x value is going to be, let's see, x equals -2, and then our y value here, this is going to say y equals -3. Right here, this point is where x equals -2 and y equals -3. Usually it might take even a longer time to figure out that intersection point. Now I know a lot of you guys must be thinking, man, Mr. Gonzalez, we've been studying this in class. There's got to be a quicker way than doing it the graphing method. Well, the nice thing is there is. See, there's another method. And what we can do is we can actually solve for this intersection right here. This is the intersection. This is the solution. These two lines are going to cross each other right here. But what we really have to understand is, what does it mean when these two lines cross each other? It means that they have the exact same y number and the exact same x number. These numbers are values that we can use. See, this y value is the same for both of these equations at the same time. Well, where does this y number come from? Where does this y value here come from? They come from these two linear equations. So this y number 1 and this y number 2, there's two different equations, so I'll call it y1 and y2. They're equal to each other. They're the same. Both of them equal -3 at the same time. So this y and this other equation y, they're both the same. They'll both be -3. So let's make them equal to each other. Well, where do these y values come from? Well, the first one comes from -2x minus 7. And the second one, this one comes from 4x plus 5. So let's see if we actually get x is equal to -2 and y is equal to -3 using this quicker method. Let's go ahead and isolate the variable. See, we've already learned how to isolate the variable as far back as last year in 7th grade. So what I'm going to do is I'm going to isolate the variable, and I'm going to go ahead and I'm going to add 2x and balance the equation. This is going to go ahead and cancel out the -2x, and this is going to give me 6x. Well, let me go ahead and get all the values without x's on the opposite side. Let me take away 5, and let me balance the equation. This is going to give me the equal sign, says that 6x is equal to -12. Well, if I isolate the variable and I divide 6x by 6 and balance the equation, guess what x ends up being? X ends up being -2. That's the exact same value that I got before. X is equal to -2 if I use this other method here. This other method right here works faster than the graphical method. You see, the reason why it works is because both of the y numbers for both of these equations should be equal to each other. Both of them are going to be equal to -3. That's why when we make the two equations equal, both of them give us the same answer, that x is equal to -2. Now I know some of you guys will be like, okay, but if I use this other method and I don't graph it, how would I find out that y is equal to -3? That's a good question. So here's what you're going to do. It doesn't matter which equation you use. You see, both of these equations right here, both are going to give you y is equal to -3. So it doesn't matter if you use the second equation or if you use the first one. Let's go ahead and use the second one. Let's put in y is equal to 4x plus 5. What number are we going to use to substitute in for x? We're going to use -2. So I'm going to take my -2 and I'm going to multiply it by 4. Then I'm going to add 5. And I'm going to see if y really does equal -3. Well, let me use my order of operations. 4 times -2 is -8. And -8 plus 5, yep, y is equal to -3, isn't it? And that's what it's supposed to be equal to, because this is where the two lines cross each other. It really does work out that way. So, what if I use the other equation though? Because I know some of you guys must be thinking, wait a minute, okay, you use this equation and y is equal to -3. But what if I use the first equation, not the second one? Will y still be equal to -3? Let's give it a try. Let's leave the equation y equals -3 there, but let's use the first one instead. Let's put y equals -2 times x minus 7. Again, what number are we going to use for x? -2. So let's take my -2 and I'm going to multiply it by my slope, which happens to be -2 again. Well, this is going to give you 4, and now I'm going to subtract that 7 here. Guess what 4 take away 7 is? It's still y equals -3. Y still equals -3. So it really doesn't matter which equation, it really doesn't. You can go ahead and get the answer quicker than having to graph both of these lines. Well, here's what I want you guys to do. I want you guys to let me give you one more practice problem. I want you to write down the practice problem that I'm going to give you right now. I want you to use the first part of this video, but I want you to pause the video after you write down this second question I'm going to give you, and you see if you can use this method instead of graphing it to find out where the two lines are going to cross each other. So let me go ahead and let me erase this for you. And what I want to do is I want to give you another practice problem. I want you to not graph it though. I want you to go ahead and use our new method, and I want you to see if you can still find out where the two lines are going to intersect, which is the solution, where they're going to cross. Let me give you y is equal to 3x minus 1, and y is equal to 2x plus 4. You see if you can find out where these two lines are going to cross each other, but I don't want you to graph it. I don't want you to find out by looking at the picture of the two lines intersecting. You know that you could do that, but I want you to use the new method. Pause the video now, get a piece of scratch paper, and then check your answer with me in a couple of minutes. I'll wait for you to pause it. Okay, welcome back. So I know that you unpaused the video now, and now you're checking your answer to see if you got the right answer here. Well, remember, when two lines cross each other on the x and the y axis, right? This is our x-axis here. And this is our y-axis right here, all right? When two lines cross each other, what they're basically doing at the same point in time is, I know this one right here, this would be at -1, okay? This right here would be -1, and the line would be going up from the left to the right. And then I know this other one, this one's going to be right about here. I'll say 1, 2, 3, 4. I know it's going to cross the y-axis at the y-intercept 4. And I know it has a slope, and it's going to be going up, but not as fast, okay? And so what I know is, at some point in time, these two lines are going to cross each other. My job is to figure out where they're going to cross each other at. That's what I'm trying to do. But I don't want to take the time of making a table, picking x numbers and y numbers, and then I have to graph the two lines. I don't want to use this slow method. I want to use the fast method. So instead of graphing it out like this, let's see if you use the new method, and let's check your answer right now. So let's see what you guys got. I'm hoping you said, okay, when the two lines cross each other, this y and this y are the same. They're equal. So y1 equals y2. This y comes from 3x minus 1, and this y comes from 2x plus 4. They're equal. Let me go ahead and isolate the variable. Let me go ahead and subtract 2x and balance the equation. 2x take away 2x. No more x's on the right side of the equal sign. 3x take away 2x. This is 1x. Now, let me go ahead and add 1 so I can move all the values that don't have x's to the opposite side. And let me balance the equation. So this is going to give me 4 plus 1 equals 5. These two lines are going to intersect where x is equal to 5. Now, what we need to do is we need to check what y is going to be equal to. See, now we want to find out what y is equal to if x is equal to 5. Now, you're probably thinking, well, which one are you going to choose? Are you going to choose this equation, Mr. Gonzalez, or this one? Why don't we choose both? Let's choose both and see what happens here. Let's take x and let's put in the number 5 right here and multiply it by 3. Let's choose x and substitute in the number 5. Let's see here. What's 3 times 5? Well, that's 15. What's 15 take away 1? Y is equal to 14, isn't it? I'll put 14 here. Now, I know some of you guys are like, wait, hold on. You didn't check this one, Ms. Gonzalez. Okay, let's check it then. What's 2 times 5? That's 10. What's 10 plus 4? It's still equal to 14. Y is still going to be equal to 14 as long as x equals 5. You see, when both of these lines cross each other, they both have the same y value and the same x value, so it doesn't matter which one we check it with. Both of them give you y is equal to 14. Hopefully your answer was right. We're going to be studying this for the next couple of weeks, and of course this is the first video on systems of equations. All right, you guys, my 8th grade YouTubers, you guys take care, and I'll see you guys later.